All right, so today's lesson is about a definite integral. So what is different about this definite integral than what you've seen so far? There's an A and a B in it. The meaning of this is the area under the curve f of x from x equals A to x equals B. So if I give you a shape on a graph like a rectangle, you can find the area of that, correct? Hopefully.
More or less.
More or less, because we have area formulas for that. But in the real world, do you need to be able to calculate area of a shape that might not be something we have a formula for? So this is the way you can find the area of all kinds of shapes if the edge of your shape can be modeled by a function. So if you can find a function that models the edge of your shape, you could then calculate the area underneath it by taking a definite integral.
You could go back in time and change the way people measure. So you could change like an inch to like this big.
Okay, so this is asking you to find the area under this curve from 1 to 3. What kind of shape is this function? That's a hard, what kind of line?
Straight.
All lines are straight.
Except for the first one.
So specifically, what kind of line is this? A horizontal line at 4. So we have this horizontal line. And then what this definite integral is asking you to find is, what is the area between 1 and 3 from that curve down to the x-axis?
Oh, so that'd be kind of this like a simple one.
So this is a very simple one, yes.
Does trig get in this?
Yes.
Oh my gosh.
Hey, wait, skip this and let's just go to trig right now.
No.
So if somebody went back in time and assassinated the trig guy, would there be trig?
Yes, because somebody else would have come up with
What if
it.
you assassinate that guy too?
Now you're talking about genocide, and we're trying to just handle definite integrals.
Don't talk about that stuff, Wyatt.
Josh, we're going to move on. How do I find the area of this rectangle? Hey, can you come back to what we're doing?
2 times 4.
2 times 4.
Good job, Josh.
So the answer to this definite integral is 8. Okay. So from our warm-up today, what if I just gave you this? Without these values of A and B. Don't you know how to integrate that? You do.
Yeah.
So what was this integral from the warm-up? That's just 4x plus c, correct? Now somehow this has got to relate to that, doesn't it?
Yeah.
I mean, it's got this integration symbol in it, yeah. Okay. So here's what you do to get from this to 8. When I put in these values of 1 and 3, you integrate it just like we have been. Then you're going to evaluate this function at 3 and at 1 and subtract those values. So if you input 3 into this, what do we get? 12 plus c. And now subtract what you get when you input 1 into this.
4 minus plus e.
4 plus c. What is going to happen to those c values?
Cancel out.
Isn't that going to happen every time that I deal with a definite integral?
Yeah.
So from here forward, when you're dealing with a definite integral, we understand the c values are going to subtract out. So is it necessary to use them anymore for definite integrals?
So we want to do indefinite integrals?
We do both, indefinite integrals and definite integrals. Indefinite, that's what we've done so far, yes sir. That did not have these limits of integration here.
Okay, I thought we had done it yet.
12 subtract 4 gives us 8.
I'm paying attention.
So that matches our area under the curve. Let's look at another example.
Newton.
30,000 AC.
So right now, I'm asking you to take a geometry approach. So I've shown you a little shortcut about how to integrate and plug in your values. But right now, you need to take a geometry approach. Let's graph this line, x plus 2. And then I'm actually asking you to calculate the area from an x value of 0 to the x value of 3.
Nice.
Okay, what is this ordered pair right here?
Right there. It's a
3, 5,
yeah.
good. And this ordered pair right here is
2, 0.
Ooh.
0, 2, sorry.
0, 2. So what shape is this?
A parallelogram.
No.
Just kidding. A quadrilateral.
A rhombus.
It is a quadrilateral. It is so not a rhombus.
A trapezoid.
A trapezoid,
You're welcome.
okay. So do we remember how to find the area of a trapezoid?
Absolutely. Base 1 plus base.
Times base 1. I don't know. Oh, wait.
Yeah. 1/2 height, base 1 plus base 2.
I have a question.
Oh, plus base.
Uh-huh.
Let's say you forget that formula. Did you just cut that sucker in half and do the triangle plus the square?
Yes, you can absolutely, it's a rectangle, but yes, you
Yeah.
can certainly do that. Okay, so what is the height of this trapezoid?
5. 3. 3. Good. Yeah.
Okay, let's review. The bases, y'all are scaring me. Have you ever had a math class before?
No.
Base 1 and base 2 have to be parallel to each other. Y'all, this is elementary school math here.
Oh.
The bases are parallel to each other.
Yeah.
The height is perpendicular to the bases.
They didn't teach us that.
Yes, they did. So what is the height value again?
3.
3. What is base 1? 2 and base 2?
5.
Okay. So it's 1/2, 3 times 2 plus 5.
I forgot how to do all this because of calculus.
Yeah, I was
Okay.
and derivative.
What do you get for this?
7.
Okay, final answer.
Oh, times 21 divided by 2, so like what? Like 10.5?
10.5. 10.5.
Put the calculator down. And what's your best you'll put trading on?
We're not going to do the full thing.
I'm not, we're going there eventually, but for right now, I'm wanting you to just use geometry and area formulas for right now, so that we have a complete understanding that this is the area under a curve. Yes.
Nerd.
Can you integrate this so far with what we know?
No.
Wouldn't that be 4 minus x squared to the 1/2? Have we done anything with... No. Only thing we know so far are our trig rules and how to use it if it has just one exponent.
Yeah.
So this you cannot integrate yet. You won't learn this for several weeks. But we can graph it. And Bennett, thank you. It is a semicircle with a radius of 2. So here's our semicircle with a radius of 2. So I have to have an area formula. So the area of a semicircle would be 1/2 pi r squared. Austin, can you come get one of these?
Oh yeah, it's 10:15.
Thank you.
Right.
Yeah. All right, so what'd you get?
Oh, don't put anything in.
2 pi? Okay, great. Okay, you can stop it there. If you would.
Cut.